Good evening, class, or presumably when you're watching this, good morning. Today we are going to cover 11.3 and 11.4, both of which are on tonight's homework. Hopefully I will be around so that we can go over 11.1, 11.2 homework. But just in case I am not, we've also got this going on. All right, so let's start by reviewing the formulas that we have already. We did area of a rectangle, which was base times height. The one main criteria is that base and height are perpendicular. We did area of a square, which is of course a rectangle, so base times height would work, but the base and the height of a square are the same and they're both the length of the side, so it's really side times side or just side squared. In section 11.2, we went on to do the area of a parallelogram, which was not a new formula. It was that base times height again. The big difference here and here is that for a rectangle, the base and the height are the lengths of the sides because sides are perpendicular. For a parallelogram, they are not. Unless they are, of course, at which point it would be a rectangle, so it works anyway. The last thing that we did was area of just a random triangle, and that is 1/2 of base times height. You can always think of a triangle as half of the rectangle. And that is as far as we got. So 11.3 starts with the area of a trapezoid. And there are two different formulas for it, and a bunch of different ways of saying it or writing it, some of which I prefer, some of which I don't, and none of which are even completely necessary, because you can always take a trapezoid and break it down into rectangles and maybe one or two triangles. But we're going to do it anyway. Let's start by taking a trapezoid and breaking it into those things, those rectangles and those triangles. So I am going to call the top base, base 1. I'm going to call the bottom base, base 2. And I will call this height, height. Okay, well, this rectangle has an area of base 1 times height. And I don't know what this length is, and it doesn't really matter. We can call it x for a moment. And since this is base 1 again, I could say that this is the whole thing, base 2. Remember, the base 2 is the whole thing, minus base 1, and also minus x. So the area of the rectangle we said was base 1 times x. The area of this triangle is 1/2 of x times h. And the area of this guy is a little bit complicated. It is 1/2 the base of this one, which is that whole convoluted thing, b2 minus b1 minus x, all times its height, which is the same as the other height, which is h. So when I add these things together, I have base 1 times height plus 1/2 xh. And let me do some distribution here, distribute both the 1/2 and the h. So I'd have a plus 1/2 b2h minus a 1/2 b1h and minus a 1/2 xh. Well, remember when I said that the x didn't matter? Here I have plus 1/2 xh. Here I have minus 1/2 xh. Those two things cancel one another out. These don't cancel, the b1h and the minus 1/2 b1h. but they do reduce. If I have a whole and I subtract a half, I'm left with a half. So I have 1/2 B1H plus 1/2 of B2H. That is a perfectly good formula for the area of a trapezoid, but not the one that I prefer. I am going to factor out a 1/2 and an H, and I get this B1 plus B2. Another perfectly adequate formula for the area of a trapezoid, but still not the one I prefer. I'm going to rearrange these a little bit, call it B1 plus B2 over 2 times H. And that's very close to the one that I like. In fact, I would accept that as being one of the ones that I like. But when I take two things, add them together, and divide by 2, I'm really finding their average. So this is my preference that we call it the average of the bases times the height. Average of the bases times the height. And the reason that I like that one so much is that it works for every quadrilateral on this list. For a rectangle, both bases are the same, so when I average them, I just get one of those bases. Oh, base times height. We mentioned that a square is a rectangle. Obviously, it works for that. Here's this one again. Well, triangle, huh? I guess I said it works for every quadrilateral on this list. And right now, I'm going to be a little strange, and I'm going to try to convince you just for a moment that a triangle is an extreme example of a quadrilateral. What I mean by that was if we were in the classroom and on the board, I drew in a trapezoid like that, everyone say, yep, that looks kind of like a trapezoid to me, maybe a right trapezoid, I don't know. But what if instead I drew something, just a very small upper base, like that? Okay, you saw me do it, presumably. You saw me make that into a little base, so you knew that I was drawing a trapezoid, but it's pretty small. If I pulled someone in out of the hallway and said, what shape is this? They would probably not say trapezoid. They would probably say, oh yeah, it's a triangle. And so let's say that it's kind of a little bit of both. It is a trapezoid with this base, which I'm going to call base 1, and base 2, I'm going to say has a length which is approximately 0. And so when I average these two things out, the average of 0 and base 1 is base 1 over 2. Hi, Buggy. We're going to pause here. I'm teaching a lesson. All right. Well, there is a small child in the corner, and hopefully it will be quiet. We shall see. What we were saying was the average of 0 and base 1 is base 1 over 2, and average of bases times the height is another way of writing the formula for the area of a triangle. So even that works. Area of a trapezoid, I'm going to say, is average of the bases all times height. There is, however, another formula, and that is the median times the height. Now, a median we've dealt with in the past. We have not really dealt with them. They are your shoes on the wrong feet, sweetheart. The median of a trapezoid is the line which runs right through the halfway mark. So that and that have to be congruent. This and this have to be congruent. And this is the median. The median times the height, and once again, those things are perpendicular. The leg is not the height. The height is the perpendicular distance from base to base. But the median will have a length which is exactly that of the average base. Sometimes I tell my students the story of Goldilocks and the 3 trapezoids. I'm sure you've heard it. Goldilocks was tromping through the forest one day, and she came across 3 trapezoids. And the first trapezoid, she said, you know what? I'm going to approximate the area as a rectangle using the same height of the trapezoid. but just that upper base. And she used this rectangle, but that rectangle was too small. Hi, Buggy. Goldilocks and the three trapezoids. Okay, this rectangle was too small. And so for the second trapezoid, Goldilocks attempted to estimate the area with the bottom base. But that rectangle was too big. So instead, she made a rectangle using the median as the width, and that rectangle was just right. Looks like it's a little bit too small on the bottom, but also a little bit too big on the top, and those two things cancel out. So those are the two formulas for the area of a trapezoid. Okay, the other figure that we need to deal with, or set of figures, one should say, are kites. And the book says kites and related figures. Remember that a rhombus is a kite and a square is a rhombus. So a square, a rhombus, a kite, they all use these formulas as well. Let me draw in a nice generic looking kite here. I'm going to draw in this diagonal of it to really emphasize the point that a kite is two isosceles triangles sharing the same base, kind of pointing in different directions. This diagonal I'm going to call diagonal 1, and the other diagonal I'm not going to draw in, but I will call it diagonal 2. Well, here is the height of one of those triangles, and the other triangle has a height, which I could call height 2, but is equal to the height of the whole figure, which is the diagonal, minus the height of the other triangle. So diagonal 2 minus height 1. So I split this into two regions. I'm going to find the area of each of them. The area of this one, it is a triangle. It is base times height divided by 2, or 1/2 base times height. 1/2 is 1/2. The base is diagonal 1, and the height is that height 1. This one, area is 1/2 base times height again. 1/2 is 1/2. It has the same base, just happens to be on top, diagonal 1. And the height is this expression over here, d2 minus h1. So to find the area of the entire kite, I'm going to add these two things together. So the area of my kite is equal to 1/2 diagonal 1 times height 1. And I'm going to distribute as I go, plus 1/2 of d1 d2, and then minus 1/2 d1 h1, minus 1/2 d1 h1. Wait a second. I see a positive 1/2 d1 h1 and a negative 1/2 d1 h1. They cancel out. Area of a kite is simply 1/2 diagonal 1 times diagonal 2. I do emphasize that multiplication in there. I cannot tell you how many formulas I have seen which are incorrect, which have addition in there instead. So 1/2 diagonal 1, diagonal 2. Doesn't seem too bad. Of course, in the book, we will be mixing it up, making it a little bit interesting, maybe not telling you straight out exactly what both diagonals are, having you find it, maybe with a 30, 60, 90 triangle, maybe a 45, 45, 90, maybe one of the triangles which are famous for the lengths of their sides. That is it. Do give the homework a shot, and I will see you guys soon.